everyone, this video is going to cover about intervals, decreasing and increasing, or a reminder of those, and how to graph a function kind of at a little bit lower level, like middle school level. So this is in particular for my 7th grade accelerated or 8th grade math class. So let's just look real quick and remind ourselves from section 7.5 in the 8th grade kind of what the graph looks like and what each portion means. So if we are going up to the right, then we've looked at this in graphing as well. That means our slope is positive because we're rising. And so this is an increasing interval. This graph happens to have more intervals. If it has a flat line, that's a constant interval. And then if it's down to the right, then it is a decreasing interval, or the slope of just this line here happens to be negative. So up to the right is positive, down to the right is negative, flat is a constant interval. And then we kind of looked at different intervals of time where it's rising, flat, or constant, and decreasing, and things like that in the last section. And then this 7.6 is like sketching from maybe a word problem. So my first example here is, well, I'm just going to read it real quick. When you draw a graph without actual data, you are making a sketch. A sketch can help you visualize relationships. Consider this following situation. An athlete measures her pulse rate during a 50-minute workout. The workout includes a 10-minute warm-up period and a 5-minute cool-down period. Sketch and label a graph showing her pulse rate during her workout. So, here's the steps that they kind of tell you, right? That we have to think about the two variables. Basically, we're looking at time and that rate of your pulse. Those are our two things. And so they put T for time, R for rate, pulse rate. Look for keywords to describe your relationship. Warm up means you're increasing, right? So I start low and then I work my way up on a warm up, on our pulse rate. Cool down means you're starting to decrease. So we know that we had 50 total minutes. So the first 10 was warm up. And so they're just talking about how to find the this part 3. They're looking at how to find the steady, or how many minutes you're steady for. But anyway, I would probably start with, okay, 10 minutes is that increasing pulse rate. So 0 to 10 minutes. I don't have a label here because I don't know what the pulse rate went up to, right? So warm up and then you're steady until you're cool down. So if I took the 50 minutes and took off the 10 minutes, right? Then I'm at 40 minutes, but we have the 5 minutes for the cool down. So we know from here to here is the full 40, but we want 5 minutes to be the cool down. So we're going to go up to 45 minutes with the steady rate and then down for our cool down. So your graph would look something like this. This may have been a line, but I mean, it's still going to be similar. Oh, I liked this example. So let's look at this one. These two situations, oops, this camera being broken really messes with me here. These two situations describes actions that take place after school. Match each description with its corresponding graph. You leave home, you ride your bike to the library, where you stay for a while doing research for a science project or report. Then you ride to your friend's house. Okay, that's situation number 1, or A. The second one, you ride your bicycle home from soccer practice. On the way home, you stop at a friend's house for a while, and then you go straight home. So, which one is going with this one, and which one is going with this one? Okay, so we leave our home and ride our bike to the library, where we stay for a while doing, then we ride to our friend's house. So I will show you like kind of their way of thinking through it. So they say, as you ride home, is this the right? Oh yeah, as you ride from home to the library, the distance from your home, it is increasing the further you get from your house. So they were saying like, okay, so this is our distance from home. So we're going to go up to the library, stay, and then ride to our friends. So the one that has the up, stay, up, we're even further away from being home. Then this one, they say for soccer, so you started not at home. So, oops, you didn't start at home. You started at soccer, went home, stayed, and then, or stopped with your friends and then went home. So those are kind of, I thought you'd have to think a little bit to think about the decreasing or that the distance from home. So I was trying to think where they go straight home and just leave. In Math Excel, when you do these, you make sure you read that we're talking the distance from home on the left side of your graph versus time, because they give you the graphs. That will help you with the problem. So like for example, like, oh, I don't know, whatever this one is talking about right here, it has total people, and then it was like going down, down, and then versus our time. So you know what they're talking about. This one in particular says, write a description for the given graph. So explain how you know whether an interval is increasing, decreasing, or constant. This one's just saying like, write a description for this, like what's going on. Well, I start with lots of people, and then it's constant, then some leave. Then I have lots of people, then all of them leave. So maybe, you could describe that in a couple different ways depending on how you think about it. Anyway, so for these problems that you're doing, make sure you're just looking at it going up and then back down on your graph. Remember that if it talks about input or xput, your x and y, either way that you want to think about this. Oops, this keeps like falling and showing stuff that shouldn't be. So let's look at this graph again. So this is our x value, which is time. It's also our input or our domain. The output on our functions is our y-axis, and it is our output is our range on a function. So those are all words that they could use for those. I'm going to show a little bit of 7-7. That's our problem solving, so usually I don't make a video for you, but I want to remind you of a couple things. Like they show a function. Oops, oh my goodness, this silly thing. I'm ordering a new one. So they show a function here. So make a table of values and find the range or the rate of change for this. So what is the rate of change? Remember, rate is what you're going up by, right? It is the slope. That is always the number in front of the x or the number that you're going up by on your output, your y. So I think that gets a little confusing when they talk rate, but you just need to know a rate is a slope. So that is 2. Okay? If you have a graph, remember you can pick 2 points and you go up and over to see that 2. Up 2 over 1 is the fraction. So that's 2 as your slope, and that's increasing. So I think that's like the only example they really get. They don't give very many examples for 2 or for 7-7 in the 8th grade. It would be a different section in 7th accelerated. Basically, you're looking at some charts and you're deciding if it's linear or non-linear, which remember, linear is a line. Non-linear might be something like this one, not a line. You can use a graphing calculator to help you a little if you're given something that's confusing and you just need to see what it looks like, if it forms a line or not. It would have a constant rate if it is a line. So here's an example in the homework. So this one here, oops, I pushed a button. Hopefully it doesn't like. So this one here has an x plus 2 squared in the formula there. And it says describe whether the function is linear or nonlinear. And then you have to use the graph. Well, the graph isn't what I'm worried about. You guys can plug in numbers, add them, square them, minus. That's not the problem. Is this going to form a line or not? Well, fill out your chart and graph it. Is it a line? Yes, no. Okay, so you're gonna have to plug in some values in order to figure out if something is a line and is a function.